Hello there. In this video, I'm going to start getting into what's called hypothesis testing. Now, before you get into anything for this video, there's a few documents you're going to need to have in front of you. You're going to need those standard normal curves. I remember I had a PDF of, I believe it was 8 of them. You're going to need that in front of you. Also, you're going to need the z-score distribution table. You're going to need this, which is called the hypothesis test flow chart. You're going to need this, which can be found underneath of, I believe, lesson examples. It is called the Introduction to Hypothesis Testing. And then this one, which I'm use these for every lesson. It is then 8-2 z-test for a mean. I am covering 2 sections with this lesson because the first part in the first section is very short and very quick. Now, the first section, what it starts off with is it starts off talking about this thing called a critical value. A critical value is like a cutoff on a standard normal curve. Alpha is a value or how much you have inside of a tail or tails in total. So for this, since it says two-tail test, one, I will have the normal curve. And then since it says two tails, that means I'm going to have a cutoff on the left and a cutoff on the right. Now, for this, I'm going to use the alpha to determine how much I have in each tail or tails. So this says alpha in total is 0.10. Since I have two tails, that means alpha is combined from both. So what I have to do is I have to take 0.10 and divide it by 2. 0.10 divided by 2 will give me 0.05, which is how much I will have in each tail. Now, as before, determine how much is left over, which would be 0.45 because each side is a half. And now you're going to have to use the z-table to figure out the z-score that corresponds to 0.45. Now you'll notice inside the z-score table, around 0.45 there's an asterisk, because 0.45 is exactly between two z-scores. Z-scores are 2 decimals unless you have one of the 2 asterisks on the table, in which you look at the bottom of the table. So here's where 0.45 lands. And at the bottom, it says if you have 0.45, use 1.645, because that's exactly halfway between the z-score that corresponds to those areas. So that means this would be 1.645, and this would be negative 1.645. The only time you use 3 decimals for z-scores is if you have one of those 2 asterisk values. And what those are your critical values, which I'm going to shorthand as CV. So my critical values would be positive and negative 1.645. Now I have a left tail. What that means is I have my cutoff on the left side somewhere. I don't care where it is, just give yourself some space to be able to write. Alpha is how much you have in a tail or tails. So here it would be 0.01. And to figure out the leftover, you would take 0.5 minus 0.01, which would give you 0.49. Now you have to look up 0.49 inside of the table and find what number's closest. Inside of the table for 0.49, it's right here. 0.4901, which corresponds to a z-score of 2.33. Now this would be negative because it's to the left of 0. So here I only have one critical value, which would be negative 2.33. Now I'm going to get into hypotheses. And what I want to do is state what's called the null and alternate hypotheses. Here's where you're going to use this handout. The null hypotheses, which is shorthanded as H sub 0, always has an equal part. H sub 1, the alternate, or sometimes called alternative hypotheses, it never has an equal to part. Now I want to symbolically write what I would have for null and alternate hypotheses of each sentence. You are never going to be given both. You're only going to be given one of those two. But these are going to be opposite of each other, or complements of each other. So the average weight of dogs is 15.6 pounds. I will have H sub 0 and H sub 1. It's talking about the average weight, which is going to be mu. Is means equals, so that means it goes here for H sub 0, so equals 15.6. Now what would be the complement or opposite of equaling? That means not equaling. And that gives me H sub 1. Now a little more than what it mentions, this would then be called my claim. How do I know? Because that's what I am actually told here. So now it says the average farm size in 1970 was less than 390 acres. Less than has no equal to part, which means it's an alternate. And less than 390. What's the opposite of being less than 390? That's greater than or equal to 390. You notice I'm leaving off the acres, the pounds here. That's okay. Because for hypotheses, you just want the numerical value, that's all. And yes, I'm starting off with H sub 0 on top, H sub 1 on bottom, because 0 comes before 1. Just makes it a little simpler. And I want you to always write these in the exact same way. H sub 0 on top of H sub 1. I'm going to have to be very, very strict about how you write everything for this lesson and what's to come, because you're going to have a lot of writing all over the place, and I want to make sure no matter where I look, I always know where to find the information I need. So the average cost of a cell phone is at least $200. I already know I'm going to have H sub 0, H sub 1, and mu for both. So is at least. That means greater than or equal. Equal to part corresponds with null hypotheses. What's the other direction of being bigger or equal to 200? That's less than 200. And this would be my claim. Now it says there are fewer than 10 students that did their first assignment. Fewer has no equal to part, which means it would fall into the alternate hypotheses, and it's fewer than 10. The complement of fewer than 10, greater than or equal to 10. And this part down here would be my claim. Now, what else you can get from this. So this really small short sentence actually gives you a ton of information. What it gives you is it gives you null and alternate hypotheses. Also gives you the claim. But it also will tell you what type of tail test you're going to be doing. So if you look back at this 8-1 intro to hypotheses testing, you always determine the tail test by looking at H sub 1. Less than for H sub 1 means left tail, greater than means right tail, not equal means two tails. So let me go back through and enter that part. This right here, the less than, which is H sub 1, tells me this would be a two-tail test. Or I'm sorry, a left tail test. Less than, left tail. Less than, left tail. You don't always have left tail. These are just ending up that way. And above it, not equal would mean two tails. Now where does this come into play? It comes into play with what came before. So you are going to be told your alphas. You're not anymore going to be told which type of tail test it is. You're going to have to use the information from the alternate hypotheses to determine that yourself. Left tail means you're going to have a critical value on the left. Right tail means critical value on the right. Two tail would mean two critical values on each side, and you have to divide alpha by 2. So that's everything from the section 8.1. Now I'm going to move to the next section. Now for the next section, I'm going to be taking my questions from this handout, which is 8-2 z-test for a mean, and you're also going to need this handout in front of you as well. It might be good to print out this one, because this one you're going to be using quite often for the next few weeks. And this is a little flow chart for the hypotheses testing. Now the first question that's mentioned is, it says perform a hypothesis test to answer this question. Now here's where I want to make sure all of you write your answers in the exact same locations as I am writing mine. And you're labeling everything in the exact same way in which I'm labeling. So you'll see that I have already off to the side the standard normal curve. So I want for you to have your standard normal curve right off to the right as well. So leaving some space. And I'm going to be referring back to this hypothesis testing PDF to use as a guideline for going through the entire hypothesis testing process. So the first thing it says is I'm going to need to state the hypotheses and identify my claim. So let's start reading. The average moviegoer sees 8.5 movies a year. A moviegoer is defined as a person who sees at least one movie in a theater in a 12-month period. A random sample of 40 moviegoers from a large university revealed that the average number of movies seen per person was 9.6. The population standard deviation was 3.2 movies. At the 0.05 level of significance, can it be concluded that this represents a difference from the national average? So the first thing I need to do is identify the hypotheses. And I will label that out, which is going to be H sub 0, null, H sub 1, alternate. Now I need to read and figure out, what am I actually testing? What's the claim that's being made here? Well, they're saying that the average moviegoer sees 8.5 movies a year. Then it gives information about the sample. Mu talks about a population. So the hypothesis or claim that's given is the average moviegoer sees 8.5 movies a year. Sees means equals. They are seeing exactly that many. So the opposite would be not equals. And make sure to write claim next to this, so that way I don't have to reread this at the end to determine which was my claim. Now the alternate determines the tail test, so not equals means two tails. Now I need the alpha, and nowhere here does it mention the word alpha. But what it does mention is this thing called level of significance. Level of significance is the same thing as alpha. So alpha would equal 0.05. Now since it's two tails, that means 0.05 is from both tails. So I have to divide this by 2. And that gives me 0.025 in both tails. If I have 0.025 in one tail, I take 1/2 minus this, and that will tell me how much is left over, which ends up being 0.475. Go to your z-score table, and you'd need to find the z-score that corresponds to 0.475. That's going to be 1.96. So I have my hypotheses. After that I have my critical values, which are here positive and negative 1.96. And again, yes, I want you to write everything in exact same locations I'm having it written. So right underneath hypotheses, you can put CV, which all know implies critical value. The next thing we need to do is find the test statistic. Well, right now you're only working for z-scores, for means, so you're going to use this formula. Z equals x bar minus mu, all on top of population standard deviation divided by square root n. Mu is always whatever's here. I don't care if it doesn't have to say equals, it could say greater than. Whatever number you have here associated in any way with mu is going to be your value for mu itself. Now you'll have to reread to figure out what you would have for a sample mean. The sample mean it mentioned was 9.6. The population standard deviation was 3.2, and this situation happened to look at 40 people. Punch all of this into your calculator all at once, and you will get a test of a z-score equaling 2.17. Now take this and put it on your picture. 2.17 somewhere over off to the right. The next thing mentioned, it says, is you are going to need to determine if you accept or reject the null hypotheses. To determine if you are going to accept or reject the null hypotheses, you want to see the location of the test statistic. Is that test inside or outside of your tail? If the test is outside, what you're going to do is essentially accept the null hypotheses. If the test is inside, you're going to reject the null hypotheses. So let's look back at the picture. So for our picture, we have the test statistic, and it happens to be inside of the tail. So since the test is inside of the tail, what you're going to do is reject the null hypotheses. So for my decision, I'm going to need to reject null hypotheses. And you can shorthand it as that. The next thing you're going to have is you will have your conclusion. Now, to figure out the conclusion, that is the purpose of the flowchart handout. So I'll first start off by writing conclusion, and I'm going to need another piece of next page for it. So for the conclusion, it says, does the original claim contain the condition of equality? And this is why I want you to write down claim next to whatever it is once you write down your hypothesis, so you don't have to go back and double check. So did the original claim contain the condition of equality? Yes, it did, because it said equals in matching with the claim. So then it says, do you reject the null hypotheses? Well, yes, we did. We did reject the null hypotheses because our test was inside. So that means we need to start off by writing this entire sentence. And yes, your wording of your final conclusion will start off with one of these four every single time. So I'll go back and start writing. So it says, there is sufficient evidence to warrant rejection of the claim. And then it just gave dots. So here's where you're going to have to go back and reread what it mentioned. Now, when you state this claim in your conclusion, you're going to need to make sure to give every detail possible. I can't just write rejection of the claim mu equals 8.5. If you write mu equals 8.5, whomever's reading this, they have no idea what mu equals, they have no idea what 8.5 equals. So you're going to have to go back and reread and say, claim that the average moviegoer sees 8.5 movies per year. Do you have to put per year? Yes, you do. Because if you don't, it could be questionable of, do they see 8.5 movies a week, a day? Do they watch that many in a month? So you do need to give the details in your conclusion. Now, it did ask another question, so make sure to answer after this any question of which was asked extra. It said, Can it be concluded that this represents a difference from the national average? Yes, it does. Yes, this is different than the national average. And this is everything in this exact same way. I would like to see all of you do this. You might understand why, because there is a bunch going on here. And yes, this will take up a lot of paper. So the next question says, a researcher claims that the yearly consumption of pop per person is at least 52 gallons. In a random sample of 50 randomly selected people, the mean of the yearly consumption was 56.3 gallons. The standard deviation of the population is 3.5 gallons. Is the researcher's claim valid? So I'll first need to identify my hypotheses. Which will be h sub 0 and h sub 1. And now what are you trying to test? What you're trying to test is, it says, is at least 52 gallons. At least has an equal to part. So here would be my claim that's being tested. The other direction of bigger than or equal to 52 is less than 52. Alternate, it determines tail, so pointing to the left, left tail. Now this does not mention alpha at all. It's very rare, but sometimes you might not be given alpha. Alpha, if you read throughout your book, it does say that it's a small value. Generally, alpha is going to be 10% or less, 0.10 or smaller. Very common values are going to be 0.05, 0.1, and usually 0.10. For this, I'm going to use alpha as 0.01. So I have 0.01 inside here. Now yes, depending on what you choose for alpha, you could essentially get maybe a different result. Sometimes it might happen that it doesn't matter what you choose here, you'll always get the same result, and other times it could make a difference. So for my leftover, underneath or inside the curve, I would have 0.49. Look that up on the z-score table, and it corresponds with 2.33, which would be negative because I'm on the left side. So I have my critical value of negative 2.33. And now I need to determine the test statistic. So my mu is 52 because that's the number associated with mu in some way, shape, or form. My sample mean was 56.3. My standard deviation was 3.5. And this worked with 50 people, so square root of 50. Punch all of that in at once into a calculator. And you should end up with, I believe it's 8.69. Yeah, that's huge. But sometimes this happens. Now I'll have to put 8.69 on my picture, which will be just somewhere over here. And next I'll have my decision and conclusion. So for my decision, I looked to determine where location-wise is this test. Is the test inside or outside the tail? My tail's right here. It's outside the tail. If the test is outside of the tail, I accept H sub O. I know I put fail to reject because I believe that is what the flowchart wording uses, or maybe your book uses, but you can just say you accept H sub 0. Now I can write the conclusion for this. So go back to the flowchart. Did the original claim contain equality? Yes, it did. Do you reject null hypotheses? You accept it because the z-score, your test, was outside or failed to reject. So this is the beginning of your sentence. So there isn't sufficient evidence to warrant rejection. Of the claim. And what was that claim? It was that the yearly, if you put annual, that's fine as well. Pop consumption is at least 52 gallons. Was there any other part of this extra question asked? They said, is the researcher's claim valid? So this said we're accepting null hypotheses. So, yes, that was their claim, so their claim is valid. So the last question says that the average number of miles a person drives per day is 24. A researcher wishes to see if people over the age 60 drive less than 24 miles per day. The researcher selects a random sample of 49 drivers over the age 60 and finds the mean number of miles driven is 22.8. The population standard deviation is 3.5 miles. At alpha equaling 0.05, is there sufficient evidence to support the claim? So start off stating hypotheses. And what is it that you are wanting to test? I know this says is, which means equals. But what they are looking to test is they said they wish us to see if people drive less than 24 miles per day. So their claim is actually right down here, and it's less than 24 miles, which means the H sub 0 would actually be greater than or equal to 24. So be careful and focus on what is it that you're actually testing. or what hypotheses are you actually testing? Now, alternate always gives you tail test, points to the left, less than. Did it give me alpha? Yes. It says 0.05. Since it's one tail, 0.05 is entirely there, which means this is 0.45. You are going to see repetitive critical values. 0.45, like one a couple before, would correspond to 1.645, and it would be negative. Next, I need to do the test statistic. So my sample mean was 22.8. My mu, whatever is associated with mu in any way, shape, or form, here it's 24. Population standard deviation, it said, was 3.5, and this ended up looking at 49 people. Punch all of that into a calculator at once, and you end up with negative 2.40. Take this and put it on your picture. Negative 2.40 is to the left of my critical value. It doesn't matter where, just put it somewhere over there. So is that inside or outside of the tail? This is inside of the tail, which gives me my decision. My decision, if the critical value is inside the tail, is to reject null hypotheses. For the conclusion, I look at the flowchart. Does the original claim contain equality? No, it did not. Do you reject null hypotheses? Yes, because the test was inside the tail. So here's the beginning of my sentence. So the sample data support the claim. And the claim here is that people over 60 years old drive less than 24 miles per day. And let me see if there's any other part of the question there. So it said, is there sufficient evidence to support the claim? I essentially said yes, and have that in the wording of the conclusion itself, because it says the sample data support the claim. We are going to be doing this hypothesis testing for a while, so if there's any parts of this you're uncertain, contact me, let me know. And again, I do want to see everything in this order with every hypothesis, CV, critical value test, decision, conclusion, picture on to the right for all of your work. I'll see you in the next video.